Welcome back to e-learning. In this video we are going to discuss about the intersection of two sets. Union we have discussed in the previous video. Okay, so let's begin. Here you can see there are two sets A and B. Okay, so if any elements are common in this these two sets, that will be kept in this shaded area, shaded part, blue color shaded part. Okay, and let's see there are two sets A, in that common element A, B, C. One more set B, in that common element C, D, F. So what is the common element? What is the same element, similar element? Let's see. A is present in A and B both? No, only in A it is there. B, no, B is also not same. Here only C, D, F. Okay, so here C is common in both the sets. Which element is common? C, as we can say. So we will keep in this shaded part. Which element we can keep? C. C we will keep here. Okay, in shaded part. Okay, in shaded part here we can keep C. So this will show our intersection. Clear? Now disjoint set. What are the disjoint set? One more concept are there. Disjoint set. Two set which does not have any common element. There is no common element in these two sets. All elements are different. They are called disjoint set. Let's take one example. So one set. One second. So A is one set. In that common elements of set A, B, C, and set B elements are D, E, F. Is any element common? No, there is no element common because here A, B, C, here D, E, F. No element is same. So we can see these two sets are disjoint set. A and B are the disjoint set. A and B are the disjoint set. Okay, and you can see we can represent these two disjoint set by two separate circles. Okay, but they both are the subset of universal set, right? Because they belong to universal set only. Okay, some properties of based on these operations, union, intersection, all. So first property, A intersection B equal to B intersection A. It means if we find common elements, first A and then B, and B and A both will be same. Let's check. Suppose A common element A, B, C, not common element. Again I am repeating the same thing. Elements of set A. Okay, and B elements of B are C, D, F. C, D, F. Which element is common? So A intersection B is equal, which element is common? C. If we find B intersection C, B intersection C में first we will check B then C. Which is common? Only which element is common? Only C is common. C is common element. So we can say C is common element. So in both the cases A intersection B equals to B intersection C. A intersection B is equals to B intersection A. Okay, so this property is true. This is called commutative property. Same thing we can check one more property, that is associative property. These properties actually we have discussed in the 6th or 7th standard when we were discussing about the integers. Okay, closure property, commutative property, associative property, identity. Okay, so let's see, these are the A intersection B intersection C, A intersection B intersection C. So one set, that is A, 1, 2, 3, these three elements, and set B, 2, 3, and set C, they are 3, 4, 5. These are three set. Now we'll find their intersection. Okay, so in A intersection B, which element is common? We can say 2 and 3. 2, 3, 2, 3 are common element A intersection B. Now let's find A intersection B intersection C. So let's see, A intersection 2, 3, A intersection B 2, 3, and C 3, 4, 5. So 3 is common element. Which element is common? 3. You can see here 3. A second. Here also 3 and intersect also 3. So 3 is the common element. Which element is common? 3. That we can write here. Sec. Okay. Now we'll check for vice versa. So B intersection C. First we will find B intersection C. So here we will check B and C sets. Which one is the common element? B and C. Which is the common element we can take? 3 is common element between B and C. Which element? 3. Okay, 3 is common element. Now let's keep 3 in this set. Okay, now A intersection B intersection C. So for that we will check this set A and this one set. This B intersection C. This one set. One sec. This set. So let's check here 3 element is 3. In here also which element is given? 3 only common. Because the B intersection C only one element 3. And in the A, in set A, 3 elements are there. So only 3 is common in both the sets. So we can keep 3. Which element? 3. So now we will check this is this one. This one is A intersection B intersection 3 and this is A intersection B intersection 3. So same elements are there. It's only one element 3 is common, so we can say A intersection B intersection C. This identity we can prove. Which identity? This one. Second one. Now let's see xi intersection A equals to xi. Xi means empty set. Okay. So empty set means there is no element and one more set A. In that 1, 2, 2 elements are there. Now are you able to find any common element in these both? No. No element. It means the xi intersection A is equals to empty set. Empty set means xi only. So this property also true. The next one we will check fourth property, universal set intersection A. So universal set, suppose there is a universal set U. In that common element 2, 3, 4, 5, 6. Okay, and one set A. In that element 1, 2, 3. Fine. So U intersection A is equals to, what is the common element in both? Let's see. 2 is common first. Okay, 3 is common. 3 is common. So there are 2 elements which are common between a universal set and set A. So 2, 3. So this will be the union intersection A. So fourth property, sorry. So there is a universal set U. 1, 2, 3, 4. Universal set means all elements which are present in its subset. Okay, like A. So A is a subset of universal set, means all elements of A should be present in U. Then only U can be set, you can be defined as a universal set. So let's find out their intersection. U intersection A. Okay, so U intersection A bole to which elements are common in both? Only 2. 2 is common element and one more element 3. ठीक है, 3. ठीक है. So now how many elements are common? 2 elements, 2, 3, which is equals to A. Means these 2 or 3 elements are present in A. So we can say U intersection A is equals to A. Right? So this property is true. This one property. This one property is true. Clear? Now we'll see fourth property, that A intersection A is equals to A. If we take intersection of itself, then it will be set only. Okay, let's begin. A element A, B, C. Okay, and if we find its intersection, what will the intersection? Same itself, na? See here, A intersection A, common element between A, that's this only, ABC. So we can say, what we can say, A intersection A is equals to A. So these are the operations. Okay, the last one property on based on operations, this is the distributive property. Okay, this is distributive property. So A intersection B union C, that is equals to A intersection B union A intersection C. So let's see this property. So A is one set. Okay, in that element 1, 2, 3, fine. One more set B in that element 2, 3. Another set in that elements are 2, 3, 4. Clear? So first we will find B union C. Bracket is there. We should solve bracket first. So let's begin B union C. So B union means combine. So B union C, all the elements we have to keep together, but elements should not be repeated. So B means first we will keep elements of B. 2, 3 we kept. Now these 2, 3 is repeating in the C. So only which is not repeating 4. So we will keep 4 only. Because 2, 3 already it is, if you write it will come 2 times. So only one time we have to write. We should not repeat the element. That's a B union C. Now we have to find A intersection. A intersection B union C. Okay. So 2, 3, 4 B union C. Now A. In the A we have to find common element in A. So here in this set A and B union C, we have to see common element. Which are the common element? 2, 3. 2, 3 are the common element. Okay. So which are the common element? 2, 3. Right. So this is one set we got, that is A intersection B union C. A intersection B union C. Now let's see another. That is us right hand side, A intersection B union A intersection C. Let's find A intersection B. A intersection B. Which is the common element in both? So as we know, set A is 1, 2, 3. Okay. Another set is 2, 3. Third set C, that has element 2, 3, 4. So first we will see this A intersection B. So let's find A intersection B. So what is the A intersection B? Elements which are common in A and B, that we call A intersection B. Which are common element A intersection B? 2, 3. Okay, 2, 3 are common element. So let's write 2, 3 common elements between A intersection B. Now let's find A intersection C. So A and C, which are the common element? Here also 2, 3. 2, 3. These are the common element between A and C. So 2, 3. Okay. If we combine all the elements, so A intersection B union A intersection C. So if we combine both the sets element, which set we are getting? 2, 3. Only these two elements we are getting. The same thing we got when we were finding the A intersection B. Sorry, it was A intersection B union C. A intersection B union C. Here also we got element 2 comma 3. Okay, and the right hand side, which is A intersection B union A intersection B, there also we are getting element 2 3. So we can say this property also true. Now these property we can show with the help of Venn diagram easily. So let's see. First we will see B union C. Three sets are there, ABC, B union C. So this shaded part here till here, this shaded part, blue color shade part, it is showing B union C, means all the elements which are common in B and C. Okay, and this part, it is showing A intersection B, mean which is common between A and B. This part, all elements common between A and B, this blue color part shows.